Now, so in the previous lecture, I have told that the expression for gamma, that is the propagation constant of the wave, this can be written as alpha plus j beta, and which is equal to root of zy. Now, if we put the value of z as r plus j omega l and value of y as expression of y as g plus j omega c, we will get like this expression. Now this inside square root we have to write in terms of alpha plus j beta. So if we square this, that means what? Alpha plus j beta is equal to this term. So if we do square both sides, if we square both sides, we will get alpha square plus 2j alpha beta minus beta square equal to this. Like this we will get the expression. Now in this equation we have to equate real and imaginary part. So real part is alpha square minus beta square. This if we equate with Rg minus omega square Lc. So we get like this equation. And if I equate the imaginary part, here the imaginary part is 2 alpha beta. This is equal to the this part omega Lg plus Cr. So this is just squared. 2 alpha beta equal to omega into Lg plus Cr, and it has been squared. So we get like this. Now in this equation, this alpha square value if I put here, then I will get the expression for beta. So if I put this expression, I will get this as the expression of beta. Similarly, once we got beta, and then from you put this beta square here, you will get the expression for alpha. So beta and alpha expressions will come like this. They are little big, but you have to keep in mind. Now if I consider the line to be perfect, that means lossless, when r is 0, g is 0, you will see that it reduces to such a simple form, beta equal to omega root Lc. Like this it reduces. That is how the expression reduces. And the velocity of, we know that velocity is omega by beta, so we get like this. Now let us move on to another important concept, that is the distortionless line. Now what do you mean by waveform distortion? Now we know that the expression for alpha is given by this expression. This is the expression for alpha. So you see that alpha is complex function of frequency. Now suppose on the transmission line we are transmitting our voice. Our voice has different frequency components. So different frequency components will be attenuated in a different way. Different frequency components will have different amount of attenuation. So in the receiver side, different frequency components will change its amplitude depending upon attenuation. So the waveform will be distorted. This type of distortion is called frequency distortion. Now another type of distortion is there. We know that if you see the expression of beta, it is complex. Okay, it is very complex equation. Now velocity is given by omega by beta. So velocity becomes, so if you put beta expression here, you see that velocity becomes a complex function of frequency. That means different frequency components will travel through transmission line with different velocity. So in the receiver side, some frequency components will come early and some frequency components will come late. So this will give rise to delay distortion. So this is known as delay distortion or the phase distortion. Because see, if different frequency components of our voice, they come at different times, so our voice will totally change. That means our voice waveform will get totally distorted. Okay, now frequency distortion can be reduced in transmission line by use of equalizers at the line terminal. Frequency distortion. Okay, so these circuits are networks whose frequency phase can be adjusted to be inverse of those of the line, and that way we can avoid the frequency distortion. Now, so I want to have my transmission line to be distortionless. So if I want to have a distortionless line, first let us see how we can avoid the delay distortion or the phase distortion. That is V equals to omega by beta. If I want to make the velocity as independent of frequency, velocity should be independent of frequency, so that all frequency components they arrive at the same time in the receiving end and there is no delay distortion. So this is possible only if beta is a direct function of omega. Say omega into something, so omega will cancel and velocity will become independent. So how this can be done? You see the expression of beta. In this expression, if I take this term, what is inside the second square root, this term if I write as rg, plus omega square lc, that means inside this square root term, if I write rg plus omega square lc, so what will happen? rg will cancel and omega square lc plus omega square lc will become 2 into omega square lc. Then this 2 and this 2 will cancel out. Here 2 omega square lc will come, 2 will cancel out, and I will get root over omega square lc. Only this term will come. So, and root over of omega square lc means beta will come as omega root lc beta. So in this way beta will become omega root lc. So now velocity is omega by beta. Beta is omega root lc. So omega will cancel. So velocity will become independent of frequency. So in this way delay distortion can be avoided. So what we are doing, this inside this term I am writing as rg plus omega square lc, or if I do square, it is this inside the square root term. So what is my requirement? This rg, this term, that is rg minus, so rg, this term, this should be equal to rg plus omega square lc square. So this, if I read this equation which I got, this equation that I am getting, this if I rearrange, it will reduce to this form, Lg minus Cr square equal to 0. That means Lg equal to Cr. So this can be written in more popular way, that is R by L equal to C by G by R by L equal to G by C. So this is the condition for avoiding the delay distortion or the phase distortion. Okay, in the next video we will see another distortion, how to avoid.